Let's look at how we can create an animated road mender scene. This is what we wish to achieve in this particular project. Model railways can be brought to life by the use of animated cameos, as we've seen in the two exhibition layouts that we have within WASAG. This animation attempts to recreate a typical road menders scene from the 1940s right through to the 1950s. The main feature is an animated Abeling and Porter road roller. And the scene is complemented by the use of working stop-go signs, a glowing workman's brazier, and a flickering oil lamp on a warning barrier. This is the road roller. It's a 1/76th scale Abeling and Porter. It's manufactured by Oxford. There are several reasons why I chose this particular road roller. It's highly detailed, as you can see, and it's specifically used for mending roads. Hence, in the foreground, you can see the boiler used for heating the tower. In addition, it's a die-cast model. It has strength, and the roller and the wheels are fully functional. The animation will be via a threaded rod and motor, and this is as per the road roller on the WASAG exhibition layout, back and forth. Let's take a look at the road roller mechanism in some detail during its construction stage. The principle is that if a nut on a threaded rod is held captive while the rod is turned, the nut will progress along the thread. By attaching a carriage to the nut, this enables the road roller to be propelled along the length of the rod and then returned by reversing the rotation of that rod. You'll see the rod is held at either end of the travel by two substantial bearings. In the center, you'll see the captive nut on the carriage. And here at the far right, we see a geared motor with a flexible connection. The motor, bought from eBay, is geared to provide us with significant torque. Turning the board over, we can see that a piece of shaped plastic card is attached to the carriage, which protrudes from the upper side and connects with the road roller. Now, this is the road roller motion control board. The board was designed by Davey, and it consists of an L293D motor driver and a custom pick. You'll see on the right-hand side of the board the contacts for the left and right micro switches. In the center, in the lower center of the board, you'll see the connections to the motor. And on the left-hand side, you'll see the connections for the separate motor voltage, which in this case is 12 volts. The pick receives signals from the micro switches at either end of the travel. And this switches the polarity of the motor via the L293D driver. Here we can see some detail of the L293D motor driver. It can handle two motors. In this case, we're only handling one. You can see the connection to the motor. The chip is driven by 5-volt supply, and there is a separate motor voltage, which in this case is 12 volts DC. The X and Y are controlled by the PIC, and below you can see the truth table, which provides either a clockwise or an anti-clockwise turn of the motor, and the two conditions which will stop the motor. This is a close-up of the carriage showing the brass shoe, which contacts the microswitch and closes it. The microswitch is at either end of the travel, and they send a signal to the PIC that the carriage has arrived. Here we have a close-up of the motor control board, and below, this is the WTV020 soundboard that we've seen in previous animations. The soundboard is loaded with the road roller sounds and contained in the microSD card. Let's take a brief look at the sequence of the animation as controlled by the PIC. We start with an initialization. This means that we need to start the road roller from a known position each time. This initialization ensures that wherever the road roller stops on its previous outing, it will be brought to the same position prior to the animation starting for real. We have a short waiting period predetermined. We then switch the motor polarity to ensure that the road roller will head off in the correct direction. At the same time, we will activate the soundboard, which provides us with the sound of the road roller. The carriage will move off. At the far end of the travel, the carriage will activate a microswitch, which stops the carriage and also switches off the sound. Again, we have a waiting period. This is simply to add to the realism of the road roller moving to the end of its travel, waiting for a few moments, and then reversing its direction. We then repeat this sequence in the opposite direction for as many times as we wish. Finally, the animation will be stopped for as many minutes as we wish. And then the whole sequence will be started again. So this provides us with quite a lot of flexibility within the PIC to determine how many times the road roller will move along its travel, and then for how long a period of time we will have it shut down before the animation starts back up. Now, having gone through the basis of the mechanism, let's take a look at it in action. Here we have the initialization. It's moving to the right, and you'll see it's about to hit the microswitch and stop. We have a pause. The direction is reversed, the sound kicks in. We reach the far end. Microstick will be tripped. Motion and sound stop, and the direction is reversed. And so it goes on. Let's take a look at the stop-go animation. The animation uses two easy points kits to control a sign at either end of the scene. Both kits have identical settings and use the same trigger to ensure simultaneous operation. This is completely independent from the road roller and could therefore be used as a standalone animation. This was first used on our exhibition layout up and down. This is the Road Menders brazia. Very, very simple animation. And of course, it has many applications throughout different parts of a railway scene, town scene, and as is still used today across any era. Now we can see it glowing away in the background. It's simply a 00 scale plastic barrel, which is drilled out, and then small holes are drilled through the side. A flickering orange 3mm LED is inserted, and it's powered by 12 volts via a 3.3K dropping resistor. We can finish this off with some fine coal, weather it, and then it's ready for use. The Road Menders lamp, again, a very, very simple animation, and yet quite an effective one. A flickering Road Menders lamp can be easily made by using a 1.8mm red LED. We paint the body to the desired color and leave the bullnose red. The body color could be red, black, white, all depends on your particular application. But I would advise providing an undercoat of black until you can ensure that there is no bleed through the plastic body. This is then widened series with a hidden flickering LED and a 5.6K resistor or higher to a 12 volt supply with microliths wire. And there we have a Road Menders lamp. Or it could also be a coach tail lamp. or a guards van tail lamp. If you're using modern era rolling stock, then you could substitute a flashing rather than a flickering LED. Here are some of the references that I've used, not for the first time. From Davies' book, chapter 14, Adding Sound, which gives all the details of the sound module, the WTV-020, how to create AD4 files and so forth. Also, the intro to PICS projects for the basic program required for the PIC. The recent LED presentation contains information that you would need on how to provide a flickering effect from a standard LED. And finally, from the BBC Sound Archives, the actual sound of a steam road roller. And now let's look at the finished item on my layout. I hope this has given you some food for thought. It's yet another fairly simple animation that can run quite happily unattended while you're doing other stuff on your layout. Now I will open up the session so you can ask any questions that you wish.